Okay, let's go ahead and try the same thing. Let's get a grammar for Java identifiers. So first step, just like giving examples of the data in the design recipe or coming up with test cases, let's come up with some examples of Java identifiers so we know what our grammar needs to be able to generate. So what are some good Java identifiers? N, yeah, that's a Java identifier. Num students. XYZ94. Okay. What else? I go ahead and I can switch back and forth between letters and digits and uppercase. Yeah, pretty good. What else can I have in there? Oh, I get underscores in my Java identifiers, right? Okay, so these are all things that I'm going to want to be able to generate from my grammar. And I even think of things length many, length 1, length 0. Can't have a Java identifier of length 0. I have to have at least one character. What else? Can we have letters or digits? Actually, there's one restriction about digits, right? Can't start with a digit. Okay, so that's good to know. I can't start with a digit. Underscores. Can I start with underscore? Heck yeah. Can I have a really short identifier that's only a single underscore? Turns out I can. Yeah, okay. Gosh, so I want to have a grammar that generates some of these things we saw before. So here's the trick. I want to say, hey, I can go and make more and more letters. The same trick we used when saying, hey, I'm going to want to make more and more adjectives in front of my noun. Okay, so here's what I'm going to do. I'm going to go ahead. First of all, I'm going to have a helper. A helper non-terminal called digits, okay? And it's not going to be too bad. It's going to be 0 or 1 or 2. Let me see if I can go ahead and cyclically finish this whole thing off. Okay, whew, good. Digits, and then I'll go ahead and I'll call them, I don't know, maybe Java letters. Java letters are going to be, A through Z, upper lowercase, and let's see, one other weird Java letter, underscore. Yeah, so underscore or uppercase A or uppercase B or pod or ... lowercase c. Okay. And I'm going to have, digit. I shouldn't really call this digits because what does this non-terminal expand to? A single digit. So digit and Java letter. Let me go ahead and do that. Now I'm ready to start my identifier, okay? What is a Java identifier? So I'll call it a Java ID. Java identifier has to start with a letter and then can be followed by any number of digits or letters, okay? So starts with a Java letter, followed by, which I've already defined, followed by 0 or more letters and digits. So I'll call this digits or Java letters plural. Digit and Java letters? I don't know. Okay, I need to define what this is. Okay, this is the thing that I'm going to want to make recursive that can get pumped over and over again. And notice that this name is definitely plural because this non-terminal is going to generate many digits or Java letters. Digits or Java letters. We'll go ahead and do the interesting part first, the recursive case or our base case. Let's go ahead and do the base case first here. I might have, again, Java ID might want to generate n. Okay, well, how would that happen? Java ID would go and generate a Java letter, which is going to go and generate n, lowercase, and it can do that. And so this needs to generate the empty string. So one thing we can do, digits or Java letters can go ahead and generate the empty string, which again in our rules we'll write as an epsilon. Okay. Now we want to have say, hey, I want somebody to be able to pump this rule and pop out a digit or a letter, followed by many more digits or letters, possibly. Digits or Java letters can also be, gosh, it can be digit followed by digits or Java letters. Okay, and finally it can be a Java letter followed by digits or Java letters. How do I have an extra S in there? There we are. Actually, now that I think about this, this sounds a little bit like repeated code. This rule is doing the same thing. It's like either throw in a digit or a Java letter in front of this non-terminal that's letting me add as many as I like before I stop. Gosh, if I really want to refactor my code here, I'll go ahead and have one more non-terminal digit or Java letter, and it can go to either digit or Java letter. It's kind of a self-naming. And now I can go ahead and have one rule here using that extra digit or Java letter singular followed by digits or Java letters plural. Okay. Now, this refactoring here I just did, you might say, gosh, Bartlett, you went from having 2 rules for digits or Java letters to 1 rule for that, but 1 rule for digit or Java letter singular. Yeah, so maybe 6 of one, half dozen of the other. It feels better this way to me. Okay. Okay. This will go ahead and do it. Let's go ahead and make a derivation. Now derive some strings from Java ID. Okay, let's do ahead. Java ID can go to, say I just want to get n. Let's look at our test cases that we had, our example today. Yeah, okay, I just want to get n. How to get that from Java ID? Go ahead and write down the derivation of the identifier n coming from Java ID. Go ahead and pause and unpause. Thank you. Derivations have this double arrow. Okay, Java ID double arrow. I only have one choice. There's only one right hand side for this thing here, so I'll put that in. And now I'm going to make this a I'll do a leftmost derivation. I'm going to take my leftmost non-terminal Java letter, and hey, I can turn that into n, right? There's a Java letter, and one of those hidden in that ... was n. Of course, I still have this thing here. I'm allowed to take one non-terminal and replace it with the right-hand side. Okay, so I have this. What's going to happen here? I want to get rid of this. Oh, I'm going to use the derivation digits or Java letters goes to the empty string, which I'm just going to write equals here. The string n followed by the empty string. That's the string n. So I'm showing you that, yeah, I went ahead and used rules. Should I number these rules here? Rule 1, Rule 2, Rule 3. Well, let's see. That'll be Rule 1. This will be Rule 2. This will be Rules 3A, 3B. Rule 4 is our big important one, or our top level one. Rule 5A and Rule 5B. So again, we can now say exactly which rule we used. This was by Rule 4. This one was by Rule 1N. Something like that. This is going to be by Rule 5A. And this is not a derivation, I just threw an equal sign in there. I rewrote that same string. I'm not going to, on your homeworks, you can do one or the other. I'll be okay with giving straight to n and not writing down that epsilon at all, or writing it there, but just knowing between you and me, we can take it out at any time. So, okay. Yeah, so that went ahead and gave us n. Let's go ahead and get num students, or how about, I want to go ahead and end up with n, make sure I can go ahead and get n5 underscore m. Okay, can I go ahead and do that? Yeah, so go ahead and try doing at least a few steps of this derivation. Go ahead and pause and see if you can actually write down the steps. Use your double arrow when you're doing derivations. We're no longer writing our grammar. That was the single arrow for writing the rules of the grammar. Now we're just using those. It's like we wrote our program and now we're just running our program. Okay, we made our data definition and now we're just coming up with examples of the data. Okay. Oh, good. You paused? There. Okay, now you paused. Okay. And we're back. So yeah, we can go ahead and do this. We're going to start out the same way if we want to get to n5. Okay. In fact, it's the same rule here. I'll give that n. Now I'll go a little bit different though. I'm going to go ahead and take digits or Java letters, and I'm going to use rule 5b. So that's the interesting one. Digit or Java letter, singular, followed by, that was what rule 5b was, right? Rule 5b, a single letter followed by the letters non-terminal. Okay, now I can turn this into digit or Java letter, can become digit, whatever rule that was, and then digit can go ahead and become 5. If you skipped and went straight from digit to Java letter straight to 5, you are forgetting that we don't, digit or Java letter, there was actually only one rule involving that. Well, no, sorry, two rules, 3a and 3b. So you have to use one of these two rules. So, okay. Oops. 3a. Okay, and then this became 5. So now we have n5 digit or underscore letters. I'm going to go one more to grab that underscore there. Okay. What am I going to do? I'm going to take this, digit goes to 5, that was by rule 2e, something like that. Digit can be replaced by 5. Now I want to take this digits or Java letters and I want to include another individual digit or Java letter, and that's my 5b again. That's my cool recursive rule. Again, I'm looking for n5 underscore m, so now I can go ahead and take this digit or Java letter. A single letter can be replaced by a Java letter. That was rule 3b. Okay, and then Java letter can go to underscore. That was by rule 1 underscore. So now, can you go ahead and finish that? See how it's going to finish out? I'm not going to pump the m again. You could, but well, tell you what, I'll do it in 0 time at all. I'll do it in hyperspace time. There we are. Okay. So yeah, I went ahead and did this digits or Java letters, pumped it into a single letter followed by letters, single letter, digit or letter turned into a single letter, which turned into m. Great, so now I have n5 underscore m digits or Java letters, and I want to get rid of that digits or Java letters, and that's where I can go ahead and, how do I terminate this recursion? I use that last rule there. Rule 5a, I think it was. Okay, so that's how I get n5 underscore m as a valid Java identifier. If somebody wanted to say, yeah, I'm not sure if this is really a valid Java identifier, n5 underscore m, this would be a proof, okay? Like, hey, Your Honor, we're going to court, and here I'm telling you, by these sets of rules, I've proven that Java ID can derive n5 underscore m. Okay, so we have that there. So we came up with a set of rules and really can generate all the different things there. I'll finish by, can I pull this other window up front and it shows? Yeah, okay. Let me finish by pulling up the actual Java definition. Okay, so here's their definition. They have a slightly different syntax. This is their non-terminal, and so rather than having arrow, they just have a colon. And then they have the right-hand side. And actually they have some stuff in English, a little bit fuzzy. Identifier chars, but not a keyword or Boolean literal or no literal. Okay, interesting. So what are identifier chars? It's either a Java letter, or it's identifier chars followed by Java letter or digit. Oh, okay. They're doing a little bit backwards if you look at it. They come up with a few smaller rules. They're being a little bit clever, and they're taking care of the fact that the very first thing has to be a little bit different, and they're sticking that in this rule here by saying identifier chars. The only way to end the recursion is to have a Java letter, and when you end that recursion, it's going to actually be the leftmost thing here. So, interesting. Okay. And then they have Java letter, can be any Unicode character. That is a Java letter, see below. Okay, Java letter or digit, any Unicode. So granted, I put ... in for these, so I'm not really doing much different than them. And I didn't actually mention all the Unicode stuff. But yeah, we came up with something similar. They used a little left-hand version. It's a little bit clever in certain ways, a little bit odd. I'm not going to go into the details of that. You can take a class about you can read entire books on grammars and parsing and these different variations in their strengths and weaknesses. But we'll end there with having finished our grammar. Awesome.